This is a quick lesson on initial value problems, or sometimes referred to as initial condition problems. So let's look at two examples. The first one says, find f of x given that f prime of x is equal to 2 sine x minus the square root of x, and f of 0 is equal to 4. Well, we've done antiderivatives already, so the integral of 2 sine of x minus the square root of x with respect to x, we should be able to handle that. And that's going to give us a family of functions. So we're going to have the antiderivative with a plus c. And those answers only differ visually by a vertical displacement up or down. And that's what the plus c does to our graph. But out of all those family of curves, we're looking for one specific solution, and that's the one where f of 0 is equal to 4. All right, so let's start by getting our general family of solutions here. So what's the antiderivative of 2 sine x? Well, that's going to be negative 2 cosine of x. Because the derivative of cosine is negative sine, the negatives will offset and we'll have 2 sine x. Minus, and it's x to the 1/2 power, so before we did the power rule it would be one more added on to 1/2, which would be 3/2. But when I take the derivative of x to the 3/2, I multiply that 3/2 out in front, and so I need to offset that 3/2 with a 2/3. So now when I take the derivative, 3/2 times 2/3 is just 1, and then we subtract 1 from the exponent and we get x to the 1/2. And then plus any constant. So that's the family of solutions to that integral. Now we want the one such that f of 0 is equal to 4. So what I'm going to do is I'm going to set 4 equal to negative 2 cosine, I'm plugging in 0 for every x, minus 2/3, 0 to the 3/2, plus a constant. And we need to figure out what that constant is. All right, so the cosine of 0 is 1, so negative 2 times 1 is negative 2, and then minus 0 to the 3/2, well 0 to any non-zero power is 0, so that's just going to be 0, plus c, and therefore c is equal to 6. So the solution for this particular problem, this initial value problem, is f of x equals negative 2 cosine of x minus 2/3 x to the 3/2 power plus 6. And that's the function where f prime is equal to 2 sine x minus root x and f of 0 is equal to 4. All right, let's look at one more example. Slightly more complicated. Let's find f of x. This time, though, they're giving us f double prime, or the second derivative, is 12x squared minus 4. The first derivative evaluated at 0 is negative 1, and the function evaluated at 1 is equal to 4. All right, so let's start with integrating f double prime. So 12x squared minus 4. And this is going to give us f prime of x. So integrating the second derivative will give us the first derivative. And so that's going to be x to the 3rd power. And when I take the derivative of this, I want to get a 12. So 3 times 4 would give me 12, and then x to the 2nd minus 4x plus any constant. And so this is f prime of x. Now we have the initial condition that f prime of 0 should equal negative 1. So that means I'll plug in negative 1 for f prime, and I'll plug in 0 for every x, and I'll be able to figure out what c is. And in this case, c is equal to negative 1. So now I have f prime of x is equal to 4x cubed minus 4x minus 1. Now I can find f of x by integrating f prime. So let's take the integral of 4x cubed minus 4x minus 1 with respect to x. And so that's going to be x to the 4th power. When I take that derivative, it's 4 times x, and then lower it by 1, 4x cubed, minus 2x squared minus x plus any constant. And now we have another initial condition that f of 1 is equal to 4. So when I plug in 1 for all the x's, my function will equal 4. So I get 1 to the 4th minus 2 times 1 squared minus 1 plus c. So that's 1 minus 2 is a negative 1 minus 1 is a negative 2 plus c. And here I get c is equal to 6. So therefore, f of x, which is what I was looking for, the particular solution, is going to be x to the 4th minus 2x squared minus x plus 6. And there you have it. So those are basically what initial value or initial condition problems are. The assignment is from 16C, starts on page 389.